Okay, so this is Form A from the quiz that you guys took on Friday. If you didn't have Form A, you still have the same questions, they're just not in the same spot. So hopefully you can remember. If not, not a big deal. As I said, just you can see what you got in Home Access Center, but you can follow along and see what the right answers are. That's the more important thing than what you put last week, is what the right answers are so that you get them right tomorrow. Okay. So number 1 says, Joe rides south on his bike in a straight line for 15 minutes with an average speed of 12.5 kilometers per hour. What is Joe's displacement? So the first thing that you want to do whenever you are answering a question like this is to write down the information that you have been given in the question. This is a calculation problem. So if you write down your given information, and I don't have a ton of space on here, but obviously you guys have paper right now, you could. I'm going to just label it in my question. They gave me a time, 15 minutes. They gave me a average speed, and technically I actually know the velocity because there's a direction over here too. So you could call this speed or you could call it velocity. Since it's in a straight line, they're going to have the same number value anyway. And we're looking for displacement, which is delta x. Again, we talked about this method for solving calculation problems called the guess method, where you label your givens, that was the G in guess, you label your unknown, that was the U, and then you find the equation. So we need an equation sheet to do that, and a calculator. Okay, so looking at the things I have labeled, these equations right here are the ones we have used in this unit. Okay, these first 1, 2, 3, 4, 5 are the ones from this unit. What we're looking at in this problem is going to be this one right here. Your average velocity is your displacement over your time, or it's this equation too. Delta x equals velocity times time. They're rearranged, but it's the same thing. Okay, so if we want to find that displacement, we have our equation, velocity equals displacement over time. Now, before we substitute into this equation, I cautioned you guys about this when we were doing this math the first time. The reason we want to label everything, one of the reasons we want to label everything, apart from helping us pick the equation, is so that we can see the units and make sure that they're consistent. This time is in minutes. This velocity is in kilometers per hour. Those are not consistent. Guys, this question should be super easy, and yet 58% of you got it right, which means 42% of people got it wrong. And it's probably because you didn't pay attention to the fact that this is in kilometers per hour and this is in minutes. You can't cancel one with the other unless they are the same unit. So we either need this to be in kilometers per minute, or we need this to be in hours. One or the other. I'm going to tell you right now, it is easier to convert this to hours because 15 minutes is a quarter of an hour. That's easy. I don't have to do math for that. Hopefully you don't either. 15 minutes, my time that I'm going to use is 0.25 hours. Okay, so I have a velocity, I have a time, my units are now consistent. Cool. Okay, and so we can substitute in. My velocity is 12.5. It is equal to my displacement, which I'm trying to find, divided by my time, 0.025 hours. Okay, so if I want to solve for delta x, we're going to multiply both sides by 0.25 hours. And I forgot to write my units here, but that's going to cancel the hours because this is kilometers per hour and leave us with just kilometers. So it ends up in the calculator being 12.5 times 0.25. Which is 3.13 kilometers south. I don't know where I just put the calculator that I just picked up. Oh, there it is. All right, but that is what you end up getting when you multiply 12.5 times 0.25 is 3.13 kilometers, and then of course your direction is south. Questions about number 1? Again, that was one that was heavily missed, and I'm assuming it's because you didn't notice the units that had to be converted. So be very careful when you're reading it. If you label them all out, if you list your variables, check those units and make sure that they're consistent so that things can cancel. All right, number 2. Number 2 says Usain Bolt set the current 100-meter world record at the 2009 IAAF World Championships, clocking an incredible 9.58 seconds for the 100-meter sprint. VHS principal Mr. Smith, he was last year, so technically this should say Mr. Dixon, collected the following data when he ran as part of a physics demo. And we have a data table here with his position and his time for 4 seconds. Which statement is the best conclusion to make based on your interpretation of Mr. Smith's data? So if we look at the options here, we need to figure out how fast each of them is running because the comparisons have us talking about their speeds. So that's what we need to do first, is how fast is Usain Bolt moving and how fast is Mr. Smith moving. So Usain Bolt, we can find both of their velocities with the same equation. In fact, it's the same one we used up there. Velocity is displacement over time. And so we can find Usain Bolt's velocity because we can get his displacement, 100 meters, over his time, 9.58. So 100 divided by 9.58 is 10.44, if I round it, 10.44 meters per second. All right, so that is going to be Usain Bolt's velocity based on these numbers. We can do the same thing for the principal. His total displacement is 47.9 meters because he started at 0. This is how far he is from where he started. The time it took him to do that is 4 seconds. So we can do 47.9 divided by 4, and that will give us his velocity as 11.98 meters per second. So guys, question. Do you guys think that our principal is faster than the world record holder? No. Something is probably wrong here. Okay, let's look at our choices. Because it says, which statement is the best conclusion to make based on your interpretation of Mr. Smith's data? So statement A says Mr. Smith would probably lose to Usain Bolt in a race. And while that is true, he would probably lose, it is not based on the data. You can't pick it. The data says he would win, which is ridiculous, but that's what the data says, which is why the other choices talk about there being something wrong with the data. Okay, we can't pick A. It's not supported by the data. B says Mr. Smith likely made an error in his data collection because the speeds shown by this data are too fast for Mr. Smith running, and that is the one that you should choose. Okay, there's no way that our principal is faster than the world record holder. So the answer is B. This one says it's too slow, and that's not true. Okay, so B would be your answer to number 2. 2/3 of you guys got that right. Questions about number 2? All right. Number 3, we did a little better on. 80% of us got number 3 right, which is good because this is exactly taken from My Open Math. So you have seen this picture and this question with different numbers probably, but you've seen this before. Okay, it says, on his recent physics homework, Jamal was asked to calculate the distance traveled by a man shown in the following diagram. Jamal answered that the man had traveled a distance of 60.4 meters east and saw that his answer was marked incorrect. What is the reason for this? If you look at the answer choices, they either refer to the fact that the number is wrong, or, notice this is the same number, or the direction is wrong, okay, or both in some of these. And so that's what we need to look at first, is what is distance? And let's see what we should be getting. You need to remember the difference between distance and displacement. Okay, your distance is the total path traveled. It's the sum total of all of the parts of his motion. So this right here, 23.3 meters, yes, it's going in the negative direction, but for distance, I don't care. This one's going in the positive direction, but for distance, I don't care. I just add together 37.1 plus 23.3, and if I'm looking for distance, that's all that matters. It's scalar. Okay, and so I do in fact get 60.4 meters. This part is right. Okay, the problem must be the direction, east. And the problem isn't that it's not east, it's that you should not specify a direction for distance because it is scalar. In fact, some of you probably lost points on that question the first time around for doing just that. Okay, the answer should be C. It is 60.4 meters, but you should not specify a direction as distance is scalar. It's not going west. If I had to pick a direction, which I would if this asked for displacement, then we started here, we ended here, we ended east of where we started. So east is the right direction for displacement. But displacement wouldn't be 60.4. Displacement would be 37.1 plus negative 23.3. It would end up being a subtraction problem. And you would get, if it had asked for displacement, you would get this, 13.8 meters east. Make sure you know the difference between the two. Does anybody have a question about number 3? All right. Number 4. Number 4 says a hockey puck is struck and rockets across the ice rink westward at 1.07 times 10 to the second meters per second, ending up in the goal 4.2 meters away. How much time did it take the puck to reach the goal after being hit? Again, start by labeling the information that is given to you in the question. They give us right here a value. They don't tell us what it is, but I know, and you should too, by looking at the units. Meters per second is a velocity unit. So this is a velocity. Okay, now my velocity, I can leave it in this scientific notation, but I don't really need to. 1.07 times 10 to the second is a really complicated way of just writing 107. So that's what I would recommend, is just writing 107. Write it in standard form. If you want to leave it in scientific notation, you can. You don't have to change it. But I'm going to write it as 107 meters per second west. Okay, so there's my velocity. Then they give me a displacement right here, 4.2 meters away. So there is my delta x. Okay, and then it wants to know how much time it took. So again, before you do the math, make sure your units are consistent. This is meters per second. We're good. There's no conversion needed. Okay, going back to my equation, I have velocity is displacement over time. If I substitute in, that becomes 107 equals 4.2 over t. Guys, if you're trying to solve for t, which you are, you cannot do that if it's in the denominator of a fraction. Just algebraically, because this question, this is not a hard math problem, and yet only 2/3 of you got it right. So I'm assuming 1/3 of you either had issue with the scientific notation or didn't do the algebra right. Okay, you can't solve for this when it's in the denominator. So your first step needs to be multiplying both sides by t. Okay, so now you have 107t equals 4.2. And from here, if you want to solve for t, you need to divide both sides by 107, because t would be equal to 4.2 divided by 107. And 4.2 divided by 107 is 0.039, or answer choice A, 0.039 seconds. Questions about number 4? All right, let's take a look at numbers 5 and 6. Numbers 5 and 6 both go with this same graph. It says the graph below represents the relationship between velocity and time for a kite flying through the air. Use it to help answer the following 2 questions. So there's my 2 questions. It says the shaded area under the line represents the kite's blank. So it's referring to these shaded sections. Okay, so the shaded area under the curve or line, what does it represent? And if you recall, anytime we find area, we are multiplying our axes. V times t. Guys, that's the equation right here, V times t. That is the equation for displacement. You can see it on your formula chart. Or maybe you remembered it from our notes, because I told you in class the area under a VT graph is displacement. The answer to 5 should be B. And only 53% of you got that right. So that was just straight out of the notes. Make a note of it. Okay, so I know it doesn't ask this, but I'm going to show you how to find the displacement as well, because you might see a question where you have to actually solve for it. So, just in case. Again, displacement means we're finding area. If you have something that travels at 2 meters per second for 10 seconds, which is what this part represents right here, then it will travel 20 meters, 2 times 10, forward. I know it's forward because it's positive 2. Over here, we're going negative 3 meters per second, and then from 10 to 20 seconds is 10. So again, you're finding the area, length times width, negative 3 times 10. Use the numbers on the axes. Negative 3 times 10 is negative 30 meters. Okay, and then the last one is this one here. Again, from 30 to 45 is 15 seconds, and it's moving at 1 meter per second for 15 seconds. That means it will move 15 meters, specifically positive 15. So if this question had said, what is the displacement, then you would simply add these together, keeping in mind that this one's negative. So 20 plus negative 30 is negative 10. Negative 10 plus 15 more would be positive 5. The displacement would be positive 5 meters or 5 meters forward. If, on the other hand, the question had said, what is the distance? Then I wouldn't care that this was backwards or this was forward. I would just add the numbers. 20 plus 30 is 50, plus 15 more is 65. That's how you would find each of them. Okay, so you're using the area for both, but paying attention to the sign here and not here. All right, number 6, how does the distance of the kite compare to its displacement? Well, we just found those. Okay, the distance is much greater than the displacement. Okay, and so that is A, the distance is greater, and this is true every time. Your distance will always be either greater than or equal to your displacement. They will be equal if all of your motion is in one direction. If this kite only went forward, they would be equal. But because it changes direction, they're not going to have the same magnitude anymore. Your distance will at that point be greater. Are there any questions about number 5 or number 6? Again, guys, if you do have a question, now's the time to ask. You have a test over this stuff tomorrow. All right, this graph goes with number 7 and number 8. It is a position time graph. Please pay attention to what type of graph you have. The last graph was a velocity time graph, not the same thing. Okay, so now we have a position time graph. Number 7 says, what is the distance traveled by the object in the graph above? We're not going to find area. This is a different type of graph. I can see my positions. They're labeled on the axis. If you're looking for distance, we don't care which way. We're just going to add together all of our line segments. From 0 to 5, this was 5 meters, specifically 5 meters forward, but again, I don't care about that. Then we stay in the same spot, 0 meters here. And then we go from 5 back to 0. That's 5 more meters. So when I look for my total distance, 5 and 5 is 10 meters. If it had asked for displacement, then technically this is 5 and this is negative 5, because it's backwards. And you'd get 0. Or look at where you started, where you end. You're at the same spot. Your displacement would be 0, but your distance is 10. So number 7 should be B. Number 8, what is the velocity of the object from 3 seconds to 5 seconds? So it is talking about from here to here, in this little part of the line, what is our velocity? On a position time graph, your velocity is your slope. Think about it. Slope is rise over run. Change in y over change in x. Change in position over change in time. That right there is the equation for velocity. Look, it's on the formula chart. Velocity is displacement over time. Slope is displacement over time. So guess what? Slope is velocity. You can memorize it as well, but your slope will be your velocity because that velocity is displacement over time. So if you were asked to find the slope of this segment, you can just do that segment. But sometimes the question is going to say, how fast is the object moving at 2 seconds? It's going to pick a point. Okay? If it asks you to find the velocity for something that is contained within a line segment, find the slope of the segment. The slope doesn't change. It's a straight line. So you could pick this point and this point to answer the question. Or you could use the 2 points it gave you. It doesn't matter. But if they ask you to find the velocity at a specific point in time, find the slope of the line containing that point. Okay, that is how you're going to approach that problem. So, rise over run. So from here to here or from here to here, it doesn't matter. My slope either way is going to be 1 because rise 2, run 2, 2 over 2 is 1. Or if you had done it from here, 5 over 5 is still 1. So my velocity of my object is 1, which means it's either C or D. Velocity is a vector, it needs a direction. So it's not going to be C. I need to also specify which way. The answer to number 8 should be D. Questions about number 8? Okay. Number 9. Number 9 says the XT graph below shows two runners A and B. Describe what happens at point P. Label on the graph above. This is point P right here. It's the intersection of the two lines. So what happens when two lines intersect? What does that mean on a position time graph? Well, on a position time graph, it means that your position is the same at that point in time. Okay, we have the same position at that point in time, which means that they are passing each other. Well, specifically, one of them is passing the other. If you think about what's happening in this graph, runner B starts out behind runner A. At point P, runner B has caught up to runner A, and then he passes her because then he's ahead afterward. So your answer here is runner B passes runner A. One of these other choices says they have the same speed. Guys, this is not shown here, okay? I had somebody ask about this last period. They don't have the same speed. Speed on a position time graph is slope. At no point do those two lines have the same slope. If they did, if they were parallel or even overlapping for a section where they had the same slope, then yes, they would be moving the same speed for that particular amount of time, whatever it was. Okay, but we don't have that here. Runner B is faster the whole time, and I know that because his line is steeper. Yes, sir?
So, like, you find the slope by rising the runner.
Yep.
And it's at that specific point, and it's distance over time. So, like, isn't at that point that it would be at the same speed?
No, because at that point, I still don't have the same slope. And they didn't start at the same spot. So runner A, even if I was looking at displacement over time, runner A's displacement is only whatever the difference is in those two things. Runner B's displacement would be all the way from here to there. Whatever, they're not numbered here, but whatever that is. So he has more displacement in the same amount of time. He's moving faster. Any other questions? All right, yeah, now's the good time to ask. So that was a good question. Make sure you ask it so you don't miss it tomorrow. All right, here is question 10. We were given a position time graph and asked to match it to a VT graph. You guys did an entire card sort activity where you did things like this, and I guess it paid off because 90% of you got this question right, so most of you got it correct. So you just need to look at this position time graph and think, what is this object doing? So here it's moving forward because it has a positive slope. Here it's not moving because its slope is 0. And here it's moving forward because it has a positive slope. And yes, we could figure out how fast. We could get a numeric value for the slope. But before I do that, I want to look at my answer choices and see if I can eliminate anything. Because this is forward motion, 0 motion, forward motion. So let's take a look at our choices. A shows forward motion, 0 motion, forward motion. So that looks good. C also shows forward, 0, forward. But B doesn't, and neither does D. So I have already eliminated half of my options without having to do any math, just looking at that graph. Okay, so it's either A or C. And yes, from here you would be welcome to actually solve for the slope, or just look at them relative to each other. Which one is faster? Because that's the difference here. This shows slower and faster. This one shows faster and then slower. So is it faster or slower here? Faster. And I know that because it's a steeper slope. Could I figure out what the slope is? Yes, it's 30. This one is slower. Its slope is only 10. Again, you can do that, rise over run. That's fine. Okay, but the one that shows faster forward, 0, and then slower forward is C. That is the answer to this question. And look, it's 30, 0, 10. It matches the slopes. Questions about number 10? All right. As I said, 90% of you guys got that one right. Number 11. Number 11 says, in a 4-kilometer race, a runner completes the first kilometer in 5.9 minutes, the second kilometer in 6.2 minutes, the third kilometer in 6.3 minutes, and the final kilometer in 6 minutes. The average speed of the runner for the race is approximately blank. Average speed is going to be your total distance divided by your total time. Again, it's on here. Average speed, total distance divided by total time. So my total distance is right here, 4 kilometers. Or you could read it, first kilometer, second kilometer, third, final, so there are 4 of them. Okay, so my total distance is 4. And my total time is the sum of each of these legs it gives me times for. It's going to be 5.9 plus 6.2 plus 6.3 plus 6. Add them together, that's 24.4. So 4 divided by 24.4 is what you actually need to put into the calculator in order to solve this. And that would be 0.16, which is answer choice A. And it is in kilometers per minute. Double check, but these were in minutes, and this was kilometers. Okay, so we have the right unit. And number 11 is A. Questions about number 11? All right, 87% of you got 11 right, and number 12, same thing, 87%. So it doesn't look like there's going to be a lot of questions here, but let's look at it. Number 12 says, study the motion map below, which of the following is correct. So we have 4 objects here, A, B, C, and D, and we've got some statements to read. A says D is traveling fastest while B is traveling slowest. On a motion map, you can see how fast something is traveling based on the length of the arrows. The longer the arrow is, the faster it's moving. So if D is the fastest, it should have longest arrows, and that is absolutely not true. D looks like the slowest. Okay, so A is incorrect. B says C has a negative velocity. It does, because this is the positive direction, therefore this is the negative direction. C is going negative. And D has a positive velocity. It does. This one right now looks like my answer, but let's double check first and make sure we're not missing something. Answer choice C says A is faster than B. That is not true. A's arrows are not longer than B's, so I don't even have to read the rest of the statement. The first part of it's not right. And then the last one says B and C both start at 0 meters. A starts at 2 meters. B and C, well, B does start at 0, but C ends at 0. It doesn't start there. C starts over here. So this one's not true either. The answer here should be B, that C is negative and D is positive. Questions about number 12? All right, 13. Number 13 goes along with this chart, and it says the chart below shows the mass of a baseball measured by 4 different groups. Each group took 3 measurements and found the average mass. The actual mass of the baseball is 145 grams. So the only problem I have with this is that this entire table is in kilograms. So I'm going to go ahead and convert my grams to kilograms. There are 1,000 grams in a kilogram, meaning that this mass is 0.145 kilograms. If I convert it. All right, the question here says, which of the following group's data is most accurate? We talked about 2 terms when we looked at how to examine a data set, accuracy and precision. Accuracy, which is what we're trying to find, is which group is closest to the actual value. Well, here's the actual value. So which group is closest to that? Group 4, because they got that. Look at their average. Group 4 got an average of 0.145. They are the most accurate. This should be D. However, just to cover it, what if the question had said which is most precise? Precision is how close their measurements are to each other. How consistent were they? Did they measure it the same way every time? So for consistency or precision, you're going to look at the range of their data. 0.139 to 0.143. That's pretty consistent. That's only 4 thousandths. But if you keep looking, group 3 only has 1 thousandth, 150, 149, 150. Those are very close together. It's almost perfect. Theirs is actually the closest. So if the question had said who's the most precise, it would have been group 3. But as it's written, most accurate is group 4. Questions about number 13? All right. 14. Number 14 was the second most missed question on your quiz. So I would recommend that you look at it. It says a man on a motorcycle is driving down the freeway at 100 kilometers per hour as he passes a school bus moving in the same direction at 80 kilometers per hour. A student throws a ball toward the back of the bus at 20 kilometers per hour. What is the velocity of the ball from the point of view of someone standing on the side of the road? So guys, first things first, they gave me extra information. This question does not ask about what anything looks like from the motorcycle's point of view, and it doesn't ask us to figure out how fast the motorcycle is moving with respect to anything else. I don't care about the motorcycle at all. So you can cross that part off. A man on a motorcycle, I don't care. Doesn't matter. Okay, now we just start with the school bus. And the school bus does matter because we're trying to answer how fast the ball is moving, but the ball's inside the bus. So the bus is moving 80 kilometers per hour. And the ball is on the bus. If the student was just holding the ball and riding the bus, then the ball is going to look like it's moving 80 also. But the ball is moving with respect to the bus. So I showed you guys an equation last week when we did the notes for relative velocity, and I told you can only use this equation if the velocities are both given relative to the same reference frame or relative to the Earth. You can't use that equation here because this velocity of the ball is relative to the bus. Okay, so here's the bus's motion. If the ball wasn't doing anything other than being held, it would also be moving 80, but instead somebody threw it backwards. So the bus is 80 forward, the ball's going 20 backwards. From the perspective of somebody on the side of the road, this ball is going to look like it's moving forward at 60 kilometers per hour. Instead of 80 because it got thrown backwards. If it had gotten thrown forward, it would look even faster than the bus, but that's not what happened. 60 kilometers per hour forward because it's still moving more forward than backward, and that is answer choice A. Questions about number 14? All right. We're getting close to the end. Let's go. 15. Question 15, similar scenario, in fact, identical except for the baseball. That's not on this one. It says a man on a motorcycle is driving down the freeway at 100 kilometers per hour as he passes a school bus moving in the same direction at 80 kilometers per hour. What is the relative velocity of the bus from the point of view of the man on the motorcycle? Now I need the motorcycle because it says from his point of view. And now I can use that equation I gave you last week. You can use this. Relative velocity equals the velocity of the object minus the velocity of the observer. You can use that equation now. Okay, or think about it logically. I told you about 3 different types of scenarios. If you are passing someone, which is what the motorcycle is doing, he's passing the bus. That bus will look like it's moving backwards at a slower speed. There's only one option that shows that. Okay, but if you go back to the equation, you can prove it mathematically. Because it says from the point of view of the man on the motorcycle, he becomes the observer. So the man on the motorcycle is 100, that's the observer speed. The bus is now the object and it is moving at 80. And they're both going the same direction, so I'm going to call them both positive. So the relative velocity would be 80 minus 100, which is still negative 20. Again, we said he'd be moving backwards and slower, and that's the only one that shows that. So the answer to 15 should be C. And you guys did good on that one. 89% of you got it right. It was just the other one you had trouble with. Questions about number 15? All right, number 16. Number 16 says, you drive to school from home in the morning at a speed of 10 meters per second, and it takes you 15 minutes to get to the parking lot. If you follow the same route, how fast would you need to travel to get there in 5 minutes? So, yes, you can solve this mathematically. I don't recommend it, though. Think about it logically. If it takes you 15 minutes to get there normally and you want to get there in 5, do you need to go faster or slower? Faster. Because you're trying to get there in 1/3 the amount of time. You have to go faster. So look at your answer choices. This was 10. This is not faster. That's not faster. So I've already eliminated half of them. If I want to get there in 1/3 the amount of time, I need to go 3 times faster. Okay, so I was going 10 times 3, 30. That's all you have to do for that. You could alternatively, if you want, take this velocity and this time and solve for the displacement, and then take that displacement and that time and find the velocity, but I don't know why you would do that. Also, if you do it that way, you have to do a conversion. Seconds, minutes. So again, I don't know why you would do that, but you could. Okay, instead I would recommend doing it in terms of proportional reasoning, like we just did. All right, number 17. Number 17, 86% of you got right, so you did pretty good on it. But number 18, I'm just going to tell you right now, most missed question by far. Okay, so we're going to get to that one in a second. 17 though says an empty roller coaster car has a mass of 150 kilograms and travels 20 meters per second on a straight section of track. A couple of physics students then climb into the roller coaster car, doubling its mass to 300 kilograms. If the full car completes the same track with the same velocity, how will its momentum compare? Guys, we're going to want to refer to our momentum equation. Momentum is mass times velocity. That's going to help us answer this question. So momentum is mass times velocity. And this question is saying, hey, if I double this, but I don't change the velocity, what would happen to this? Just mathematically, think about it. If you have twice the mass, but you have the same velocity, your momentum has to be twice as much mathematically, because you're multiplying this side by 2, that side's going to be twice as much also. That's your answer, D. Momentum is 2 times more. Questions about number 17? All right, as I said, number 18 was the most missed question. So if I were you, I would listen up in case if you're not already doing so, because only 30% of you got this one right. It is not good. It's a calculation. You can tell by looking at it. So let's approach it like a calculation. We're going to start by labeling the information we've been given in the question. If an object with a mass of 74 grams, so let's go ahead and say mass is 74 grams, is heading west with a momentum P is 5.2 kilogram meters per second west, because it says it right there. Okay, what is its velocity? So we've labeled the givens, we've labeled the unknown. Now we have to pick the appropriate equation. Well, it's going to be the same one we just looked at, the momentum equation. So P equals M times V. Again, part of the reason we label these is so that we can check to make sure our units are consistent. This is 74 grams. This is 5.2 kilograms times meters per second. Those are not consistent. Guys, we have to end up with the velocity, which has units of meters per second, which means we have to cancel the mass unit out. You have to do a conversion. This is probably why this one was also missed a lot. You can either convert this into grams times meters per second or convert this into kilograms. That's probably easier because it's a less messy looking unit. So that's what we're going to do. There are 1,000 grams in a kilogram. Okay, so 74 grams divided by 1,000 will get us to kilograms. Okay, because there are 1,000 grams in a kilogram. That's 0.074 kilograms. Okay, so that's how many kilograms we have. And this is our momentum in kilograms times meters per second. So now I have kilograms and kilograms. That's good. They'll cancel. Let's go back to the equation and plug it in. So the equation is down here. 5.2 equals my mass 0.074 times my velocity v. When I divide both sides by 0.074, which is what you have to do in order to get that variable by itself, this is the point where your, sorry, I forgot to write that right. This is the point where your units would cancel, because this is kilogram meters per second divided by kilograms. So those kilograms cancel out. If you want to write the units in your math, you can. And now you have velocity equals 5.2 divided by 0.074, which is going to give you 70.27 meters per second. Okay, now if you look at the answers, there is a choice for 70.27 and there's also a choice for negative 70.27. So make sure you read all of them. Because initially when we wrote this, I even put it here, I said west, it's west. West means negative, okay, which means this should be negative 70.27. I could have been better about it and put a negative on it here instead of labeling it as west, and then I would have the negative in my answer. But at least check it at the end. Okay, so the answer to number 18 should be D, negative 70.27 meters per second. Are there questions about number 18? Okay. Again, guys, your test looks like this. The multiple choice section looks like this. Your test, however, also has a free response section. And it's timed. The multiple choice, some of you took the whole period to answer these questions. You can't do that on the test. You've got to get faster. So if it's taking you that long, you're going to need to speed up. Okay. So you're going to have, I want to say 15, if I'm not mistaken, multiple choice questions. And then you'll have, I think, 2 free response, if I'm remembering right. Sometimes they have more than one part. But typically your free response will have things like calculations that you have to show all your work and your steps and solve things without having those answer choices down there. Or where you have to write and explain a scenario, so they'll have written component to it. I think you have both of those on your test tomorrow. But anyway, so you've got an idea of what to expect on the multiple choice. As far as the free response goes, I'm telling you that typically you have to work out something, a calculation by hand, and sometimes you also have to write, and I'm pretty sure you've got both of them on there. Me going over this quiz, I am recording it right now, so I'll put the video on Schoology. That way if you want to look at it again later, you can. But otherwise, you have other review materials to look at. You have all the stuff in My Open Math. You can do it in practice mode and just look at that for extra attempts. It doesn't affect your grade at all. Or you can even use a late pass if that's still available and do it that way. It won't affect your grade that way either. That'll give you extra practice. Or you can use the unit summary that is posted in Schoology for extra practice. That's also your daily grade redo. And in the past, we counted it as bonus, so I need to check on that. But anyway, that's what you have for review materials to look at. So if you have additional questions or if you want to look at your quiz specifically, then I'm going to recommend that you come after school for tutorials. But again, as a reminder, you guys do have a test tomorrow.